All right, I hope you had some success with that. I just want to point out a couple of things before I show you my graphing calculator. Number one, there is a table of values here. So in this case, just want to grab a different color here. X is the angle. So these are our X values, these guys right here. And our Y values are what actually happens if you put sine 0 into your calculator, you get 0. If you put sine pi over 2, you get 1, and so on and so forth. So we end up with these ordered pairs. Now, to graph this appropriately, you need to actually plot these ordered pairs. A half a pi and 1, so that's right there. Pi and 0, right here. 3 pi over 2 becomes negative 1, and 2 pi is equal to 0. Alternatively, you can actually get all of these values on the unit circle as well. But when we are marking a graph, we are expecting you to have these points graphed appropriately. Now, when you're drawing it, make sure you don't make it pointy like this one. That's not a graph of a sinusoidal function. It has to be a curve. And they were talking about that when we were marking diploma exams, that they're expecting you to be able to draw that as a curve. So I'm going to show you my graphing calculator. Again, mine looks a little bit different because it's an iPad version, but you can see my windows. The calculator automatically, when I enter negative 2 pi, it puts it into a decimal, so that's what your windows should look like. And we will have to adjust them later on when we deal with some transformations of trig functions, but that's the way it looks. All right, let's take a look at some of the properties of y is equal to sine x. Now, I'm going to actually talk about this if the domain is over all real numbers, not just a limited domain, because this graph goes on forever and ever and ever to the left and right. So my domain, and it doesn't matter if you put it in set builder notation or interval notation, but it's negative pi to pi, or x is an element of all real numbers. Now my range, we got to take a look at the range. This is a continuous graph that goes from negative 1 to positive 1. So again, in interval notation, oops, I meant to put a square bracket there. Or we can talk about it as y goes from negative 1 to positive 1. And again, it's an expectation you know both sets of notation, but you don't have to include both. I just am. Now, my x-intercepts. Because we're dealing with a domain of all real numbers, I got to talk about the x-intercepts over the entire domain. And this kind of links into what you've been doing with coterminal angles and general solution. So my x-intercepts happen, and I'm just going to grab a different color here, every pi, if you look at it left and right. So I'm going to indicate that as pi times n, and n is an element of integers. So we can put in any positive or negative whole number, and that will multiply it by pi, and that will give us the x-intercepts. Y-intercept, there's only one, and that's at 0. And let's look at the period. The period is one complete cycle. So if you take a look at the graph, everything after this is just repeated. So my period for this function is 2 pi. And the amplitude, I'm going to take amplitude is max minus min divided by 2. And that gives me 1 minus negative 1 divided by 2. So my amplitude is 1. And again, we'll talk about what midline is a little bit later, but I want you to understand that amplitude, if we go back up to the graph, it means from the midline, which in this case is the x-axis, the distance from the midline to the max is your amplitude, and that is 1. And the distance from your midline to the min, that again is the amplitude, and that is 1 unit. All right. Now what I'd like you to do is sketch the graph of y is equal to cosine of x. And again, fill out the table of values and make sure that you get the points. And I'll be back.